guys, welcome back. So today I'm going to talk about the flow measurement. So flow measurement, we're going to mainly talk about waves. We know that there are a lot of advantages and limitations. So this is all just something that you need to know. But in solving the problems, I'll just go straight to the formulas that we're going to use. So for the formulas that we're going to use, there are quite a lot of formulas, like different formulas that are not the same because different waves requires another formula. So I want to talk about what types of wares are there and what are the usage for each wares. So for this one, white sharp crested, we have three types of it. We have the rectangular, triangular, and the trapezoidal ware, like this. So for the rectangular one, it is used for the measuring the discharge and change the water elevation. So water discharge and water elevation. So for the triangular one, it is only used for measuring the discharge only. For the trapezoidal is like this, and the water will be flowing like this. It is used for measuring discharge and the change in water elevation, but with large head. So you might wondering what is the large head? Large head is this part here. This is a head, right? So if the head is too large, we're going to use the trapezoidal one. Okay, so as you can see that there will be different things that are going to see. We have we knocked like the triangular one that has the angular here. We also have a suppressed one. Basically, it's like this. So water is here, or the contracted one. Yep. So this is like the B, and this is the L, and the water will be flowing here. Okay. So we have a lot of things that are different, but the formulas are like slightly different as well. So CD is the discharge coefficient that is usually range from 0.6 to 0.62, and the number is like only usually, okay, so it might go up to 0.63 or over a little bit or lower than that a little bit. So don't panic if you see the CD that you have got is different from what you've seen, because this is like the general one for the sharp crested. But if it's the sharp crested rectangular suppressed discharge, so this Q will be something else, like different, 2 over 3 CD square root of 2G BH square root of H to the power of 3, like this. And the CD will be something like 0.620 plus 0.083 H over Y. So you can see that this is something that is different. Like the number coefficient in front of here and this number are different. So yeah, it it will make some sense if when we do the exercise, we will see a lot of different things here. So Y here is the height of the wear plate, and H is the head. All of them are in meter, so meter and meter, so this will be no units, dimensionless. For the broad crested, we only have one type, is the rectangular one, and while I am not saying that we're going to use this like these two formula always, because there are different circumstances and we will use it like differently in each time. So let's just wait for it, because in some books they're telling that the discharge is only like C L H N, like this, but it does not apply to every cases that we're going to see in the problems. For the flume, I guess we only have to use this one. It's quite simple because it's Not simple. I mean, like we need to derivative it, derive it, and integrate it because it says that it's a complex equation. But in this one, it's like simple equations. Okay, so now we can see that. Oh yeah, for this one, I guess this is not necessary. I thought it was a homework, so I tried to solve it, but actually it's just an additional information on our lesson. If the water depth is like 0.3 to 0.6, so we're only going to measure 1 point, and that single point is 0.6 which is around here, and we have the average velocity here. But if it's like the depth is already going to 3 meters, like the whole depth is 3 meters, so we're going to measure 2 points. It's 0.2d and 0.6d. But if it's like very deep, it's going to be like 3 points here, and we find the average velocity. So when we find the average velocity, we can substitute in this thing, and we will get this thing here for the flow rate. Yes, so just ignore this one. And okay, so now let's start doing our exercise. Um, let's read the exercise first. The problem first. So in this problem, it says that concrete sewer pipe, sewer the thing to discharge the sewage, not the people who sue. Okay, um, 4 feet, 4 feet here, and in the diameter is laid, so it has drop elevation of 1 feet and 1 feet per feet, 1,000 feet. Okay, and assume the properties are the same as those of water flows at a depth of 2 feet in the pipe. So what will be the discharge? So the question is asking us to find the discharge, which is the Q. So in this case, we're going to use the hydraulic radius. So the first one that we're going to first one that we're going to consider is the find hydraulic radius RH equals to A over P, the cross-sectional area of the flow over the wet perimeter. So in this case, of course, the sewer pipe is nothing else beside nothing else beside around a circle, one circular channel, right? So it is 1 over 8 d square pi over 1 over 2 d pi, right? Because 2 pi r is the perimeter, and it's like only half because it says how should I draw this one to make it look like realistic? Okay, so this is 4 feet, right? And it says that the water flows at the depth of 2 feet in the pipe. Yes, so what do we call that? So this will be the water. Let's say the water of the sewage is green because it's the dirty water. You will see a lot of green here instead of the color blue, right? So this is a sewage. The water is half. Why is it not going? Okay, so if it's half like this, the how do we call that? this one here. It's pi square over 4 pi, right? And it's going to divide by half, so over 4 pi over 2. So 2 is like 8, right? So this is the thing that we have here. So we can cancel out, and it's d over 4. And then the thing here that d, they said that d is 4 in diameter, right? So if it's 4 in diameter, 4 over 4 is 1 feet. Okay, so then we can continue to find the Q. I think this is just the what we have learned before. It's the, what do we call that? I forgot it. Yeah, the Manning's equation. So we can substitute it in the Manning's equation. This is just like a review, so it's like quite simple for you. When it goes like later, it will be like a lot of things to consider. Okay, so then we have Q equals to 194 over A RH2 over 3 SO. So in this case, we're saying that N is 0.013 because it's concrete, right? So let's substitute the number together. I lost my calculator again. Oh, it's here. 0.013 times with A, which is 4 feet square, D diameter, times with pi over 4 times with RH, which is 1. 1 to the power of 2 over 3 is also 1, so just write it 1. And then we have 1 feet over 1,000, the slope. So this would be this. Okay. The final answer is 45. Oh, wait, why is it 45? Okay, so it's 22.8 cubic feet per second. And that's it. That's for this question. Yeah, quite easy, right? Very easy. And that's very easy for you guys if you have watched all of my videos, because I've been talking about the Manning's equation for like a lot of videos already. So then we can continue to this one. A rectangular travel concrete channel of a 12 feet wide and a slope of 10 feet in 8,000. So this will be 10 over 8,000, which is 0.00125. Yep. And then we have design for the discharge of 600 CFS, cubic feet per second, for a water temperature of this one, 40 Fahrenheit. So estimate the depth of the flow. In this case, I think, okay, so this is the rectangular one. Yeah, it's going to be very easy too. So then we will see that first we need to, it says that trowel concrete channel, right? So the N must be 0.015. And then we have the Q, the Manning's equation as normal. I'm not sure if Manning's equation we need to write M with a capital M or just the normal one. So Q here equals to 1 N times with A times with RH2/3 times with square root of S. In this case, you don't have to find the R first because you can just substitute it in this part. It's okay, so the prefix is always the same, and then we can substitute it as by. B is the base and y is the height for the area of the rectangle, and the RH is by over b plus 2y. I mean the height of the wetted thingy. 2/3 and square root of S. So then we know the Q, right? So the Q is 600 cubic feet per second equals to 1.49 over 0.015. And then for B, it says that 12 feet times with the Y. Did they say the Y? Oh, we're trying to find a Y, right? Okay, so times Y. I'll highlight this one. And then we times with B again, 12 feet times Y. We will use the solver to solve for Y, okay, later in the calculator. And now all we have to do is to write everything that we need to know first. 12 feet plus 2Y. And then we use 2/3. And after this, we can times with square root of earlier that I told. It's 8. The slope is the 80 feet in 1,000 feet. Yep. And this is square root of 1/2. So I would like to how do we call that, minimize this equation smaller so that I can find y easier. So I'll just divide or calculate any possible number that I can do so that the calculation is a little bit easier for the calculator. But the professor did not suggest us to do that because it would be less accurate. But if you're doing in Excel, of course, it will be accurate because Excel can work, I think, more accurate than the calculator, like for solving the equations. So I don't trust my calculator. That's why I have my trust issues. So yeah. This would be 1.96 times y times 12y. Oh, I think this is like overall 12y, 12 plus 2y, and this is 2/3 times the square root of, I think I already did that, 0.0125. Okay, so I'll do anything that is as much as possible. 91.96 times 12 to the square root of 2 over 3 times with the square root of 0.00125. Answer here is 220.887. Okay, so it's quite fun because we are like trying to rearrange back and forth the equation to find the answer. 2 over 3 this way. Okay, and then we can move this one here by dividing, so I'll just use 600 divided by answer. It's 2.716 equal to this one here, y 5 over 3 over 12 plus 2y over 2 over 3. Okay, so now I can finally use the solver 2.716 alpha cal alpha x to the power of 5 over 3, and down here we have 12 plus 2 alpha x bracket power 2 over 3. So we use shift cal to solve for x. So here y is equal to, wait for a second, my calculator is running. Okay, it's running. We get that x is equal to 6.626. Tell me if you get a different number for this one. I guess we all have different number, right? Or yeah, I mean, like, there's only one answer for this one, but I might use a calculator wrong. Oh no. Did I do something wrong here? Oh yeah, it's 110 in 8,000. Okay. Meter. Oh, feet. Okay, so then we can see that we got the y, and that's the answer for this one. For this part, like, it's quite short, so I'm not trying to give it one full page for each equation, for each exercise, so I'll just use the square page for me to write it nicely for you guys. So yeah, okay, so now we can move on to the next part here. The concrete lined trapezoidal channel is what is it trying to do with at the bottom width of 10 feet, so it would like this, and this is 10 feet, and the inside slope, the side slope of one vertical to 2 horizontal design is to carry, okay, sorry, this is my mistake, a flow this is like fill in the blank exercise, a flow of 3,000 cubic feet per second. If the slope of the channel is 0.01, what would be the depth of the flow in the channel? So still it's very easy again. I think it's too short for you guys. It's too easy for you guys to know. Oh, okay, sorry. So now we assume n equals to 0.012 concrete So then we have the trapezoidal channel, and we're going to find y. Yeah, what would be the depth of the flow? So we're trying to find y. So for this case, I'm showing you another way to find it. ARH over B 8 over 3 equals to Q, which is the flow rate, so it's the same, Q or Qn, square root of S times with B 8 over 3. So we have different types of equations that you want to write so that you won't be the same with other people. So we can use, like, we find method number 1, we find the hydraulic radius for us, and then we substitute the hydraulic radius here, like substitute as number, not as equation. So this is the easiest method that we're going to use, and then we are having write the whole equation here and substitute by equation like this. And the last part that we're going to do is like having as fraction, so we can see it more clear. So it depends on people if like you feel like which one is easier, and it also depends on the kind of problem too. Okay, so 3,000, but like try to use a method for your own so that you won't be the same with other people. So 0.012, I mean this is time, not dot, okay, over 1.49 times the square root of, they said that the slope is 0.001. So the slope is not that difficult to find actually. It's only like, what do we call that? The slope is like, in some case they're giving you the slope, but in some other case they're giving you like the previous exercise, like 5 in 1,000, 50 or 80 in 1,000, or 1,000 in 80, 800. Oh wait, not 1,080. 10 in 8,000, like that. So it depends on the exercise that they're giving you. So now all we need is to find this one. Why did we use this kind of method? Because we all know here, we know everything is here. So it's better for us to do this type of fraction. So now we have 3,000 times with 0.012 over 1.49 times with square root of 0.001 and times with 10 to the power of 8 over 3. I'm talking faster than what I'm trying to type. It's 1.646. Then we can see that y over b equals to 0.9. Then I want to draw this arrow so nice, but I cannot. Y equals to 9 feet. So that's it. Cut. And paste it here. Okay, so now, we are going so fast. Let's move on to the next example. Yeah, because it's quite short. This is actually it's like this. Okay. So now please estimate the discharge to the Moye River near the East Port, Ihado, when the depth is 4 feet and I assume 0 as 0.0000 point. Why are there so many mistakes when I'm typing? Yep, 0 point. We're using the same thing here. It's not that hard again. I think, we're starting hard. Yeah, this one is starting to be a little bit harder. Yeah, trapezoidal irrigation channel. Canal. And it starts to be a little bit easy and hard again. Hard again. And now it's very, very hard. Is it the same? Yeah, this is the same here. One problem is cancelled. Okay, so now we're going to find our age. For the hydraulic radius, R H equals to A over P. I hope, like, repeating this over and over again, I hope that you guys will remember it in the exam room. Or maybe I am the one who is going to remember everything. Okay, so you might have asked, like, where's the number from? Actually, there's another figure that it's not showing in this screen. So yes, next video I will show you the figures of all the problems. I forgot to insert a figure in the problem, so that's my mistake, sorry. Then we can find, I'm being a devil for not showing you guys the figure. Just kidding. I really forgot to insert that. It's 2.4 feet. Why did I forget about it? And then we can assume that the n is this time. It says that the the material of the channel is quite different from the previous one. It has a really large n, so n equals to 0.038. Okay, so then we can find equals to 1.49. Would you like to, like, round up to 1.50? 1.50? No, you cannot do that. It's in the what is it? It's in the formula, in the instant formula, so you cannot do anything with this one. Square root of s. So then we can substitute all the numbers that we know. For 0.038 times with a, which is already given in the figure. In the figure, not in here, in the figure. 2 over 3 times with square root of this case, square root of this one, they're giving it inside this one, 0.0032. Okay, so then we can probably find, what did the question ask again? Estimate discharge. So it would be 1, 9 like this, 2 times with 300 times with 2.4 square root, and this would be 2 over 3 times the square root of 0.0032. The answer is, that's quite a lot for me. But it's the reverse, so of course it's going to be like a lot, like big numbers. I'm feeling like giving you snacks instead of a full course meal. Okay, so now we're done with the appetizer. We're having our main course. Done. Okay, so now let's read it carefully because it's quite like quite really tricky. I say it's tricky. Actually, the things are quite the same. It's like the additional for the thing there, but when it goes to the exercise, like the later exercise, it's going to relate a lot to the weir and the the flow measurement. This is not the main course yet, I guess. So now we have the chocolate soda irrigation canal is to be excavated in soil in line with aqueous gravel. The canal is to be designed for a discharge of 200 cubic feet per second, and it will have a slope of 0.016. Should I highlight all of this for the important parts here? And then what should be the magnitude of the cross-sectional area? So they're asking for the magnitude of the cross-sectional area and the hydraulic radius for the canal if it's designed to be that the erosion. Erosion is like what is it? It's the sand or the ground. No, the sand or the land is like falling apart. Yeah. So what if you don't want to have the erosion? So choose a canal cross section that will satisfy the limitation. So it's basically trying to solve an equation using the solver again. This is my prediction. Okay, so now let's start working on this exercise together. Okay, so wait a second. So now we can see that we're going to use it again and again for the Manning's equation. You guys, please love Manning's equation very well. He's going to help you in many ways. So for v, which is the velocity, equals to 1.49 over n. Like I can also try to do that, copy and paste, but I just want to make you guys remember this so that you won't have any regrets seeing this, like, oh, I cannot remember. So now we're trying to find the RH, right? So let's rearrange this together. I think this is quite simple because this is just going here and here's like the same part. So now we have u n times n, which is the coefficient, over 1.49 square root of s. And then we have RH close to okay. And then we can substitute all the numbers inside this one. Oh, why? Why is it so hard? It's very hard for me here. 3. UN, which is the velocity. 4 feet per second. Times with 0.25. Over 1 times with square root of 0.0016. What's going on? I think it's not trying to cooperate with me. 2. Okay. And then the answer is, wait, let me check the answer. 4 times 0.025 n 1.49 times the square root of 0.16 and power to no, it's no, 2.17. What is it? Feet. That's the radius, so it's feet. Oh, sorry, I made a mistake here. C. Đâm rải chương 4 con men plot. But I just thought go men click. I'm saying that like an elephant with 4 legs are going to fall, so a genius can also forget. But yeah, I'm not a genius, so I don't care. Okay, so now we can find the Hajil radius that they're asking in the problem. So we can continue to find the area. So for the area, it's very easy because it's going to be Q over V. Flow cross-sectional A equals 2 Q over U. In Q, we have 400, which is given in the exercise, 200 CFS. So we have 200 CFS here. Over U, which is the velocity, it's 4 feet per second. Answer, I guess I can predict the answer. It's 50. Yay, it's 50! No, I didn't predict it. I know you guys can also predict it as well. So then we can, let's find the P, perimeter. So in this case, we can find a perimeter by doing all the calculations, like, this way, and this is like the slope, trying to find something. But now let me show you the quicker way. What's a perimeter? P equals to perimeter, not perimeter, A over RH, right? Because RH is, what is RH again? I forgot. very hard to read this. 2.17. Okay, so this one will be 50. And this one is 2.17. Answer. I cannot predict this one. I need your help. 23.041. So it's just 1, 4. So then we can find that P is also equals to B plus 2y square root of 1 over 4, 1 square plus 2 square. You guys, like, where is 1, where's 2 from? So this is 1. Yeah, where's 1 and where's 2 from? Huh? Did I even miss that one for you? I guess I just read this one out loud. Huh? Really? Was I in the hallucination? I read something like vertical, 1 vertical to 2 horizontal, but now I cannot find it in this one. Okay, so if the slope is like this, you know that 1 square plus 2 square root to find the side of it. So it's like this, right? So it says 1 to 2. So you want to find this one, just square root 1 square plus 2 square. So it's square root of 5. Really? Ah, it's here. Yeah. 1 vertical to 2 horizontal. So that's what you have to assume in the actual trapezoidal if it's not given. Okay. I'm shocked. I was shocked, so I thought I was like hallucinating of what I was speaking. I was actually talking about it, and later soon I cannot find the reference anymore. I'm so scared. I'm so sorry for the background sound. It's a sound effect that you can never ever find it anywhere. B plus 2y square root of 5. So this thing here equals to 23.041 equals to b plus 2 square root of 5. A, which is actually b squared, oh, it's not by, it's b like this, plus 2y squared, and a is equal to 50 feet squared. Equation 1, equation 2. So it's like, what are people doing with the bumping the door? Does it help them? Using their stress or something? So this is a rectangular one, right? So it's b and y. And this part here and this part here, we need to plus it together. So then we can find from the two equations, we're going to solve them. So from my experience, you use the calculator. You use the calculator to find both dimension. So let me use the solver. 23.041 alpha cal equals to, because we have x and y, right? So x plus 2 alpha y square root of 5. How do I enter in this one? Okay, shift solve. I need to, okay. Fifty alpha equal to alpha x times with alpha y plus 2 alpha y square. Solve. Should I do something to... So if we solve it manually, this one would look like something like this: y e plus 2y, right? But we need this term to be 0. Okay, so let's pass this together. Okay, give me some seconds before I find out what's going to do. Okay, so in this case, we're going to use the solve equation. What else can we do about this one? Should we try substituting the number and try to find? Or if you guys already find the answer, you can leave this video now, because this is the end for this session. We will continue the next session with this exercise, so on. So you can just leave now if you already got the answer for B and Y, because I'm still trying to search. I think using Excel is faster, but I need to use this one, right? Because in the calculator, we can only solve the equation by having b and like ax this plus 2b like this, but there's like not x and y in the same calculation, so it's quite hard. So if equal to, I've never seen this type of equation before. I mean, I've seen it before, but I've never tried to solve it on my own. $23 alpha equals to x plus 2 alpha y square root of 5. All we need to do is to find the enter. $23 equal to, what am I doing here? I feel so bad for leaving you guys on hanging, but please hang on. I guess I will continue this in the next video. I don't even know like what to do with this one. Yes, so basically I will come back with another video with figures of every exercise. So yeah, this is all for today. I'm so sorry. We can see each other next video, and I promise to have full solution of this one. I feel so bad. Sorry guys. Okay, thank you.